Okay, so I'm just going to do two more examples, just kind of a supplement. I just didn't want to make that first video so long, but it already is. 16 minutes long. So here's two more examples if you just need a little bit more practice. So again, we've got, and honestly, I don't think that the SAT is going to have anything beyond this as far as rational exponents go. It should be a pretty simple process. They being, the SAT, College Board, AP people want you to know what a fractional exponent does. So we're going to distribute this, just like I said in the last video. We're going to distribute this because these guys are being multiplied. Now I just want to stress to you, okay, that if you think, no, let's not put equal. Let's just put an arrow here. If we had it like this, okay, 216 plus n to the 6th raised to the 2/3 power. There's nothing we can do. This thing is cooked. All right, you can't do anything with this at all except maybe plug in a number for n. This is not that. Okay, you cannot distribute an exponent over addition. That has never been the case. Just like when we did, like, say, 1 plus n to the 5th power, this is a problem. This is like a really elaborate problem. This you have to use the binomial theorem. Okay, so you can't distribute an exponent over addition, or if I even put this as subtraction, you can't do it. You have to go to the binomial theorem. So it's addition and subtraction, as you get more advanced, actually tend to be more cumbersome and more difficult to handle than multiplication and division. Okay, so just keep that in mind. It's just kind of like an SAT review or thought pattern. Like you never distribute an exponent over addition or subtraction. So let's go ahead and distribute, though, this exponent over multiplication. That's no problem. So we will do 216 to the 2/3 power. Then we will multiply n to the 6/1 times 2 to the 3rd. All right, so we distribute by multiplication. But notice that we are just dealing with exponents on the distribution. All right, so we'll take care of this guy in a second because he's easier. This is going to be 6 times 2, which is 12, over 1 times 3. So here we get 12 over 3, so that becomes 4. Okay, so 12 divided by 3 is 4. Now, if we go to 216, though, this is a little different. Remember what I said. You got to do the root first. Shrink the number, then raise him. If you raise an already large number to a higher power, it's more time-consuming to find the roots. So please, to save yourself time on the SAT, take the roots first, then raise it to the power. So let's do that. I'm going to take the 3rd root of 216 squared. Okay? Or look at it this way. It's much better to look at it like this. The 3rd root of 216 raised to the 2nd power. That's better, because this means that I have to take the 3rd root first. Then I will raise it to the 2nd power. And I have the option of doing both. I could do this, but that's a long time. That'll take you a while. Because 216 times 216 is a very large number. To find triples will take you a very long time. So take the 3rd root first. So I go into 216, and I think, okay, well, I see a 6 there. I don't know, 216 divided by 6. Look at that. Look at the draw. 36. So 30. Let's do it over here because he's defunct. 36 times 6. All right. Well, that's nice. I know that's 6 times 6. So I've got 3 6s here, and that's precisely the value that I want. Atticus, what's going on? Atticus, what are you doing over there? That sound. Atticus, can you quiet down just a little bit? I'm almost done, okay? 6 times 6. Thank you, buddy. 6 times 6 times 6. That's a triple. So that guy's going to come out, but there's nothing left. So this is the guy that's getting squared. Okay, so we have a 36 here that will attach to the n to the fourth. If we would have tried it the other way, all right, if we would have squared, okay, let's kind of do an arrow and say question mark, why would you want to do this? Take the third root of 216 squared. All right, if I did that, I would get 216 squared is going to be 46,656. Yeah, good luck trying to find a triple. All right, don't do it. So keep that in mind. Take the root first, make the number smaller, then raise him up. Okay. All right, last example, and we're going to call it. And this one's pretty simple. I mean, if you guys understand the process, we're good. What does a half power mean? It means take the square root. That's all it means. So half power, we can look at it two ways. We can look at it one way as 16 to the 1/2. And then x squared times a half. I mean, that's the distribution of the exponent. Okay, or you can look at it like this. Take the square root of 16x to the second. It doesn't matter. You know, there's no surefire way to do this. Like, you do it however you see fit. Now here, this is what we've been more trained to do, so I can take out a pair. I can take out a pair of 4s, and I can take out a pair of x's. Because remember, there's an invisible 2 here. That index is 2. So I'm done there. Okay? Or I can look at it like this. I can look at this as the square root of 16, which is 4. And then 2 times 1 is 2. Over the denominator, which is 1 times 2 is 2. And x to the first power is, x to the 2 over 2 is x to the first power. So either way, both roads lead to the same result. So it's really kind of what method do you prefer to kind of understand the situation? Now this, to me, and especially those of you that are interested in going into more advanced, hey buddy, don't fight the dog. What are you doing? Don't fight him. You're not fighting him, right? You're being nice to him and you're playing with him gently, right? Yeah. Okay, he's a puppy. All right, so I think I said my point. These guys are just... Whoa. Don't step it over. All right. Okay, so I think I said my point. And these guys are the same method. So whatever branch you want to go down, it all leads to the same result. So 4x is your answer, and that's it. All right, I got to take care of stuff. Jeez. All right. Oh, this video is longer than I thought. All right. Have a good night. Bye.